Chamber, and I'm a plant health scientist here at Bayer. I'm part of a team that does controlled environment testing looking at disease resistance in a variety of row crops. Today we're going to talk about Phytophthora root rot in soybeans. So we know Phytophthora can be a big threat to our soy crops in the field, and once we have Phytophthora in a field, we can't get rid of it. So we need multiple ways that we can attack that problem and protect our crops. We know we have good seed treatments available that can really help our plants get established when they're young, protect them from those seedling diseases. And then we also have, from a genetic standpoint, two different options. So we have resistance genes present in some of our germplasm, and what those do is those provide resistance for like an immune response against specific races of Phytophthora. These are hugely beneficial. They are effective from the time the seed is planted all the way through that germination stage and as those plants are growing. The problem with that in some cases is we have a variety of races in fields and we can't always characterize exactly what those are. And we also know that single gene resistance can sometimes be threatened by shifts in our pathogen population. So also what's very important is we have what we call partial resistance or field tolerance for Phytophthora. This is something that's going to kick in once those roots are established, and it's going to carry us all the way through the growing season. So Phytophthora tolerance is one assay that we do here in the controlled environment, and we can just walk inside a little bit and I'll show you how we do that and some of the results that we see. So for our Phytophthora field tolerance testing here in the growth chambers, what we want to do is mimic to the best of our ability what a plant might be facing in the field if it encounters Phytophthora. So we grow these directly in our cups. We use a layer method. So we plant with a soilless media to a measured amount in the bottom. We're going to cover that with a completely infested plate of the pathogen. We're going to add more growing media, and then we're going to plant on top of that. So as our plants grow and our roots establish, they're going to be forced down into that pathogen with no escape, and they're going to have to see how well they can tolerate that pathogen. So this assay only runs about 3.5 weeks, but it's very effective. And as you can see, with each of our tests, we have a set number of varieties that we do, but we always include known checks. This helps us just to determine the quality of our assay, make sure that our pathogen is viable and as virulent as we want it, and that we can get consistent results from test to test. So if you look over here, I have an array of the checks that we will use in each test. So these checks here range from a resistant, moderately resistant, MRMS, moderately susceptible to susceptible, and these will be present in each of our tests. Now, unfortunately, this test isn't prepared to where I can dump them out and show you the roots yet. We've got about another week to go, but already we can see here the varying responses that we can have to this pathogen. As those roots are rotting and struggling against that pathogen, the plants just don't grow as well. But when it's time to rate them, we'll actually look at the amount of root rot that we see, and we will go rate them on a 1 to 9 scale, 1 being 0 damage from the pathogen, and 9 being completely rotted roots and very little seedling. A lot of times we'll have seedling death in that case as well. So that look at our field tolerance assay just gives you a picture of one of the ways that we can really protect our crops in the field. I'm so thankful you were able to come and join us in the growth chambers today and just see a little bit about what we do. Have a great day, everybody.